Ever wonder how a computer can recognize your face, understand your voice, or even generate new artwork? The answer lies in something called neural networks, and today, we're diving into exactly how they work. Hi everyone. I'm excited you're here, because if you're curious about how AI learns and thinks, this video will make things click. We're going to break down neural networks into simple, understandable pieces, no jargon, no math degree needed. Brain emoji. What exactly is a neural network? A neural network is a type of machine learning model inspired by how the human brain works. Just like our brains have billions of neurons connected by synapses, artificial neural networks have neurons, little units, connected by weights. Each neuron takes in some numbers, which could be raw data or the output of another neuron, multiplies them by weights, adds them up, and then applies something called an activation function to decide what to pass along. That may sound technical, but think of it this way: each neuron is like a mini decision maker. It receives signals, tweaks them a bit, and sends a signal forward. One neuron doesn't do much alone, but stack thousands of them in layers, and suddenly you have something that can recognize a face or translate a sentence. Jigsaw emoji. How are neural networks structured? Neural networks are built in layers. The input layer takes in your data, maybe it's pixel values from an image, or audio signals from your voice. The hidden layers do the processing, finding patterns and relationships within the data. And finally, the output layer gives you a result, like, this is a dog, or this voice said the word yes. Each layer transforms the data step by step, from raw input to abstract understanding. For example, if you feed a network an image of a handwritten number, the first layer might detect simple lines and curves. The next layer might combine those into shapes. And the final layer says, hey, that looks like a 5. It's like a team of detectives, each specializing in one part of the puzzle. Bullseye emoji. How do neural networks learn? Now here's the magic: they learn by making mistakes. Let's say we want to train a neural network to tell cats from dogs. First, we give it thousands of labeled images, some cats, some dogs. At the start, the network doesn't know anything. It guesses randomly. Maybe it calls a cat a dog. No problem, that's expected. Here's what happens next: the network compares its guess to the real label. It calculates how far off it was, this is called the loss. Then it adjusts its internal weights using an algorithm called backpropagation to reduce that loss. It repeats this over and over, image after image. Gradually, it learns. It tunes itself so that certain neurons activate for cat-like features, like pointy ears or fur texture, and others for dog-like features. It's like practicing. The more examples it sees, the better it gets, just like we do. Brick emoji. Types of neural networks. Neural networks come in different forms depending on what they're used for. Fully connected networks, also called MLPs, every neuron is connected to every neuron in the next layer. These are great for basic tasks or tabular data. Convolutional neural networks, CNNs, these are the kings of image processing. CNNs use filters that scan small parts of an image to detect edges, shapes, and textures. This local processing is super efficient and powerful. Almost every image recognition AI uses CNNs. Recurrent neural networks, RNNs, these are built for sequences, like speech or text. RNNs remember what came before, which is critical when understanding language, where meaning often depends on context. Variants like LSTMs and GRUs can even remember long-term dependencies, like a name mentioned earlier in a sentence. GANs and transformers, we won't go deep into these today, but they're worth mentioning. GANs can generate entirely new content, like fake images or even music. And transformers, like the tech behind ChatGPT, are now the dominant architecture in language AI. Africa emoji. Real-world uses of neural networks. Neural networks are powering most of the AI you interact with daily. Here are just a few examples. Handwriting recognition, used by banks to digitize checks, or by apps that convert notes to text. Image classification, from facial recognition to helping doctors analyze medical scans. Voice assistants, Siri, Alexa, and Google Assistant rely on neural networks to transcribe and understand your speech. Translation tools. Modern language translation shifted from old school rules to neural models, which made them much more accurate. Gaming and robotics. Neural networks help AI beat humans in games like Go and chess, and even help robots learn to walk. They're even being used to generate art, write code, and compose music. The possibilities are growing every day. Rocket emoji. How can you start learning about neural networks? If you're feeling inspired and want to try building your own neural net, yes, you can. Here's how to begin. Brush up on machine learning basics. Know the difference between training and testing, what overfitting is, and how models are evaluated. Pick a deep learning library. Keras, with TensorFlow, is beginner-friendly. PyTorch is super popular and intuitive. Either one will work. They both let you build neural networks in just a few lines of code. Start with a simple project. Try classifying handwritten digits. The MIS dataset is perfect for this. Or build a cat versus dog classifier. Don't worry about making it perfect, focus on understanding the process. Take an online course. Andrew Ng's Deep Learning specialization on Coursera is a great intro. Fast.ai is also fantastic for hands-on learners. Join the community, explore Kaggle, read blog posts, follow AI YouTubers, and ask questions on Reddit or Stack. Don't fear the math, you don't need to know calculus on day one. Start by building things. The theory will make more sense as you go. Brain emoji. Final thoughts. Neural networks are the brain of modern AI, mimicking how we learn, but with raw computational power. They're behind the biggest breakthroughs in vision, speech, language, and creativity. What makes them so powerful is their ability to learn patterns directly from data, no hand-coded rules, no shortcuts, just pure pattern recognition at scale. And the best part? This once PhD-only field is now more accessible than ever. You can start building your own AI models with free tools and tutorials. So if you're curious about how machines learn, or want to create your own AI someday, now's the perfect time to dive in. Thanks for watching. If this helped you understand neural networks, hit that subscribe button, drop your questions in the comments, and stay tuned. Our next video is all about deep learning and how it takes these networks to the next level.